Hi guys, welcome to this tutorial. Now we're going to be focusing on how to verify smart contracts on Rootstock blockchain. But before we dive into it, I just want to talk a little about Rootstock. So Rootstock is layer 2 EVM-compatible blockchain which was built on the Bitcoin layer. So it gives you the smart contract capabilities which you have in like every EVM-compatible chain. But now it now gives you an advantage, which is the security layer backed by the Bitcoin. That's very interesting because whatever you're building as a developer on the Rootstock chain has that strong security layer, which the Bitcoin offers. And we can see its token is even pegged to the Bitcoin RBTC. So there's like less fluctuation in the gas price and even in the system as a whole. So it's a very lovely chain to build on. And right now, builders, they are very welcome to like accepting builders. Currently, there is a activator program which is currently on. You can contribute in an open source manner to their like tools, to the community, like the videos, whatever type of contributions you have. Building on Rootstock has lots of perks, as you can see, from the activator to security layer to the supports and everything. Now, you just have to build on Rootstock. Now, to verifying contract, it's very important to verify your contracts. Say, as a developer, you deploy a smart contract on the Rootstock chain and you're building a dApp. Now, lots of people who interact with your dApp, for them to trust you, need to verify your contracts. Contract verification simply means making your code visible to everyone. So when you deploy your contracts, now let me check Rootstock. Let me check any of the, let's just pick a random address, contract address. So let's say we pick this. Now, this is an example of a smart contract on the Rootstock testnet, okay? So when you click on contract, you can see this is bytecode, just some bunch of numbers and whatever. So this is the testnet. Now, usually when you deploy your contracts on the Rootstock chain or on every other chain, right? It's stored. The bytecode of that contract is stored at an address on the blockchain. Now, what you do when you're verifying your contract is that you are the behind the scenes. What's happening is that your code is being compiled into bytecode and then compared with what's been deployed already. If the two bytecode match, then your contract code would now be like uploaded here and then everybody can see it. That's simply what verification means. And it's very important to do that because it builds trust. Gives that open source feeling where everybody can read and see what is happening in the code. And that's what we're going to focus on today, how to verify smart contracts. Now, there is a resource that has been provided, in the video. You're going to see it's a GitHub repository and there are like a number of commands. All these are derived from, we're going to be using Foundry for this verification. So, and Foundry has like lots of commands, So for the purpose of simplicity, I shorten them and that's what we have here. So we're just going to, go through each of them and see how they work. Now, this is basically a Foundry project. You can go to Foundry and create a project by doing, I think, Foundry init. So there is like a command for creating a distribute. It's forge init. Okay, forge init. So you can this project is assuming that you already have like knowledge of how to use Foundry to deploy your project. Although we're going to still deploy, but like you just have that prerequisite knowledge to like use Foundry to deploy contracts. Because the focus of this video is strictly going to be verification, contract verification. All right, so let's get started. So at this point, you would have, either cloned the projects that I showed on GitHub or you created your own Foundry projects. And when you create a Foundry project, there's a basic project in it, counter.so. So we're going to deploy this project. It doesn't accept any parameter, like there's no constructor. So we're going to deploy this, verify it. Then I have another version of that same counter, but now it has constructor argument. So we're going to do for this also, deploy it and verify it. That's basically what we're going to be doing in this video. If you clone the repo I shared, if you clone the repo, you're going to see in the env, yeah, you're going to see the Rootstock Testnet RBC, because we're going to be deploying on the Rootstock Testnet and verifying on Testnet. And then the Explorer is Rootstock Block Scouts. Also, you need to get some RBTC, some test RBTC. You can get that on the Rootstock faucets. It's very fast to get your RBTC, like very, very fast. So you need to do this, because if you don't have RBTC on the testnet, you're going to face like lots of issues when you're trying to deploy and verify. Okay, now that that's stated, let's go to the README. So they're like, we're just going to follow these instructions here. Okay, so I'm going to be using cast store. I won't be pasting my private key. Why I showed my env here is because everything here are like public stuff. I just use an env to make sure that like the commands we're going to be using are very simplified. Okay, so I won't be pasting my private key. So I'll be using the cast store that comes with Foundry. If you want to know more about Castor is basically it's part of the modules in Foundry that helps in wallets and key management. So it sort of like helps you create a wallet in your terminal using your private key. So you don't always have to like type in your private key or stuff like that. That's why I'm going to be using Castor for this cast key store for this project. Now let's compile first so we can do forge build. All right, so this compiled successfully, so there's no issue with any of our contracts. We're going to copy this and let me paste this. So it says forge creates src/this. So I'm referencing the contract file, and I'm referencing the contract name itself. Then the RPC, then RSK testnet. Now this is a way to reference something in the .env file. So I'm using this because I don't want to like be copying and pasting here in my terminal. Now we also have account name and wallet name. Now this is because I'm using cast key store. So I have to type in my wallet name. All right. So now adding legacy here, without adding legacy, we're going to get an issue. Okay, yep. So even without adding legacy, so it says a value required for this, and this is because we have not we have some stuff here, but we have not loaded it into like the whole system. So we can do that by saying source.env. All right, cool. So .env. Now let's run that command again without the legacy. It should throw an error. Yep. So it says EIP1559 fields. So the chain might not support that. So we just simply add legacy. So what we're trying to do here is we're just trying to deploy a contract, and then we are going to verify that deployed contract. And this is a very simple contract, a contract that has no constructor arguments. So depending on how fast your internet is, the Rootstock chain is very fast. The speed varies on how good your internet is. All right, so this has come out well. It is deployed already. Let's check it out on Rootstock block scouts. Okay, so we paste it in. We see that it's already here. I mean, the code has been stored already on the blockchain. We have an address, but now the contract code. Okay, this automatically verified itself. So this happens sometimes where you deploy using Foundry and automatically it verifies it. There are cases where this might not happen. And in those cases, you would want to verify it yourself. And we can do that using the next command, which is this. So I'm going to just copy this and paste it in here. Okay, so it says forge verify contracts -- chain ID. So reference the chain ID. Then the verifier is block scouts. Then the verifier URL is this. So this has already been linked in the .env already. So we can see it here. All right, so we have contract address. Now the contract address is this that has just been deployed here. So we copy this and then we put it in here. All right, so it says then src, just following this format. Now, okay, So let me do this. Let me paste in the address directly. Let's see. Okay, says this has been verified already. Okay, so it skipped verification. Now this is for cases where the automatic verification does not work because it doesn't work all the time. All right. So now that we're done with that, let's move on to the next phase, which is let's deploy a contract that has constructor arguments and then try to verify that. So this is the contract that has constructor arguments. It has is we're supposed to pass in the name and then a multiplier, which is a uint 256. Now let's try to deploy that, and we're going to be using just the commands here. So we copy this, then we paste it. So we paste this in. All right. Just forge creates. We also reference now the the name of the file here is counter arguments args. Then the name is args here too. Now we also reference the RPC URL. Then I pass in my wallet's name, wallets. So my wallet's name is my wallets. All right. So then we also have the legacy. Then now we have a new parameter here. It's constructor arguments, and then it's accepting words. Args. So what we do is we pass in the args, the arguments, one after another, using spaces to like separate them. So if we check this contract, we see it accepts a name. So let's say the name of our counter is Hashio, and the number, the multiplier is, let's say, 500. I guess I deleted something. So I deleted the dash args there. Okay. All right. So wait for some time, and then so this asks me for my password. And I'm just going to wait for a few seconds for this to be mined on the transaction to be mined on the blockchain. All right, cool. So it has been deployed to this address. We check it. Let's see if it's verified automatically. All right, so we can see that in this case, it didn't verify. Okay, this is an EOA deployed to, let me check this again. It shouldn't show as an EOA. Wow, this is new. So let me check the transactions, contract creation. So I guess this should be a bug. It shouldn't show as an EOA. All right, so let's just go ahead and see. Okay, let's go ahead. Let's try to verify this because this shows here that contract creation successful. Let's try to verify this, contract. Okay, so if we verify this, we're going to use, verify an already deployed contract with constructor arguments. So we're going to use this copy and then we paste it in the terminal. Okay, but now we know that this is the contract address. So we change this to the contract address. Then we know the name is counter ads. And it should be ads. Okay, ads. Okay, so what else do we have? Forage verify contract. The chain ID. The chain ID would be 31. 31 would be 31. And where you can get, the information about chain ID should be chain lists. Chain list, yeah. Here you can check out, just search Rootstock and then include testnets. So you should see, details about, Rootstock and everything here. So let's see what's happening. Now, the constructor argument you pass in when you're trying to verify must match that was passed in when you deploy the contract. So here we have Casio 8 and then 18.0. So we're going to make this else we're going to get an error in that case. So you see the constructor arguments here. We used casts and then it was ABI encoded using the constructor and then the arguments. And then we pass in the the verifier URL, explorer URL, and then the contract. So let's run this. So it's taking time to do the process behind, and boom. So it says already verified. Let's check this. So let me reload. All right, cool. So you see, it's no longer showing the EOA anymore. So that's really quite funny. But it now shows like, okay, the contracts, and then we can see the contracts here. All right, so we have verified this successfully. Okay, so let's move on to the next thing. Now, what we did just was, deploying a contract, and then after deploying it, we now verify it. What if we want to deploy and verify at the same, using just one command? So it happens that, Foundry has that already. So we can deploy and verify at the same time using this command here. Okay, so let me clear the terminal and then paste it. So we see forge, create. Now we're doing it for the contract that doesn't have, constructor arguments. So we reference the contract file and then the contract name, then the RPC URL, the same way we referenced it. That's how we reference stuff that comes from the EMV file. Then the account name, my wallet, broadcasts to broadcast the transaction. Then the legacy, we have the verify flag, and then the verifier block scouts. Okay, and then we have verify URL this. All right, so let's run it. So this command will deploy the smart contracts and verify it. So that means you don't have to go to press of, oh, I want to deploy first, then after deploying I have to verify. You can do it all together. So this is already mining the transaction on the blockchain already. Okay, so this is processing, like I said earlier, based on your internet speed. This would vary for different persons. All right, this has been mined already, and boom, it says verifying, it says pending in queue. Cool. So it says contract successfully verified. And we can just, it gave us a URL, can copy and then paste directly on our browser, and then we can see that it's verified at just, a go using one command. So we can see the code here. Also, one of the perks of verifying the contract is people get to also see the ABI and other stuff too. Unlike just without it being verified, you only have the bytecode. Now the next thing we're going to do is deploy and verify contracts with constructor arguments. Okay, so we're going to copy this. Basically, these two are like the same thing. It's just that the one with the constructor argument just have like a little twist to it, and which is the constructor argument flag. Okay, so now we know that we're using different files and contracts to portray, the two different cases. So I'm going to have to add, the args here, and then the RPC is referenced well. The accounts, okay, yes, is referenced well. We have the broadcast, legacy, verify flag, verifier URL, constructor argument. Now this is arg1, arg2, so we have to pass in the arguments that once. Now when we deployed the contract, this one with argument first, and we were verifying, we had to like, okay, whatever argument we passed in when we were deploying have to be passed in again when verifying. Like it must not be different. If they are different, then verification is just going to fail. But now here we get to set it just once, so you don't have to remember anything. You just have to like do it once, and then we can just set, let's say we can set this to Euler, and the number can be 600. Okay, I started mining the transaction on the blockchain, and we just have to wait a few seconds for it to deploy the contracts and verify all at once. Okay, so I think out of all of this, my best should be, the deploy and verify at once, because it just makes everything easier. Like you don't need to remember stuff. It just does everything once. Or the commands can be like quite a bit longer than just when you're trying to verify alone or when you're trying to like deploy alone. So, but then doing it together just like makes it very, very seamless. And boom, in one instance, we're done. It says contract verified successfully. It gives us a URL, and then we can visit this URL, we'll copy and paste, and then we can see it's verified already. So depending on which way you're gonna go, you're just gonna choose what works for you. But personally, I really love this. Very spontaneous. In one instance, does everything. Now I've already talked about possible, I spoke about possible cases of failure, which is like, okay, we saw the fact that we didn't use the legacy flag, and then we had the EIP 1559 error, and we had to like use the legacy flag there because it had to like force us to use like older versions, the legacy version, not the latest version, so we can like skip the 1559 error. And there are also other types of errors like the address error that we faced earlier. Let me check the document here. We can see some other errors, the invalid API key. So the block scout that we're using here doesn't require any API key, so we didn't encounter this issue. All right, so we have compiler version commits for verify. Okay, this really encounter this. And signature error. Okay, so this would happen in cases where like I'm using my key store now. In cases where I use wrong key store, or okay, cases where I use the wrong key store, so you have to make sure that you use the right private key, like your correct private key. And like using the key store is like the best way to like avoid cases like this. They fail to parse token. We also faced this already, like EIP 1559 not activated, and have lots of errors. Errors, when you're trying to use the ABI encode. When we're using this command, if what you're passing in here didn't match what the constructor arguments you used to deploy the contracts, if the arguments which you're passing in to verify that contract is not the same as what you use to deploy it, you're gonna have errors due to the ABI encoding here. So these are like the little things that you need to like put into consideration when you're trying to like verify a contract. And for more, you can just check out this Foundry document and this Foundry page and read more about it. And I think that's basically it, because verification is not so complex. We just have to like be very conscious of the commands we're typing in, and the variables we're using to verify the contracts. And thank you for watching, guys. It's been a very interesting ride. I'm showing you guys how to like verify contracts on Rootstock. And yeah, I believe from now on, when you write contracts, you're not just going to leave it, deploy your contract and leave it. You are going to verify your contract which you're deploying on Rootstock, because it gives your users or people that want to use your product or your dApps, it gives them more confidence. It helps you build trust and transparency, because people can see what is happening in your code, and it's not like some obscure thing. All right. And that, my friends, that's the end of the whole guide. And yep, wishing you guys the best, and keep, building on Rootstock, keep contributing to Rootstock. And yeah, let's make this